Welcome to a top-tier engineering project. Today, we will transform a drill case from Makita into a portable power station with a massive capacity. It features a smart management board and a true pure sine wave inverter. Its power can simultaneously run a rice cooker, a grill, and even a circular saw, a hammer drill, and an arc welder. Let's start with the heart of the system, the pure sine wave inverter. This board provides a continuous power output of 1200 double. Remove the aluminum heatsink to reveal the power. Components. Connect a dedicated mini FNIRSI oscilloscope to measure the output pulse. The screen displays a perfect wave of pure sine at a 50 Hz frequency. The protective casing is an original Makita case, made from ABS plastic, capable of withstanding heavy impacts in construction environments. The drill mold insert is completely removed to free up space. The main power source consists of lithium iron phosphate, or LiFePO4 battery cells, in the standard 32140 size. Each cell provides a capacity of 15 Ah. Using a FNIRSI tester to check internal resistance, it shows a perfect 1.88 milliohms. The voltage is extremely consistent, ideal for assembling into a high discharge battery pack. The battery cells are fed into a machine to apply positive terminal insulation stickers semi-automatically. These barley paper insulation rings prevent short circuits absolutely between the terminals and the outer casing. The Makita plastic case is washed to remove dirt before construction. Proceed to assemble the battery pack using a honeycomb positioning plastic frame system. The connection configuration is 8S5P, meaning 8 in series and 5 in parallel. The total is 40 cells, creating a 25.6 V 75 Ah battery pack. Lightly tap with a rubber mallet so the battery cells sit deep into the plastic joints. Add a red insulation sticker to enhance safety for the positive terminal. The entire battery pack is flipped over and tapped with a mallet to ensure even flatness on both sides. Test fit the giant battery pack and inverter board into the plastic case to check the fit. Next, prepare 2 cooling fans of DC 12V 0.2A equipped with LED rings. Cut off the connectors and test the power supply to check the lighting effects. A red-rimmed LED fan exhausts hot air, and a blue-rimmed LED fan intakes cold air. The brain of the battery is the smart JK BMS management board with integrated Bluetooth. 1. Supports continuous discharge current up to 200 A and peak discharge of 350 A. 2. The 2A active balancing feature helps eliminate voltage deviation between battery series. Next, proceed to place the battery pack into the spot welder, which is fully automated via CNC. It uses 0.25 mm thick pure nickel strips with a cut slit design by CNC. This middle slit forces the welding current to go deep into the contact layer of the battery casing. This creates deep, solid weld spots that are extremely secure and prevent heat generation. The Z-axis of the CNC machine moves precisely across each positive and negative electrode surface. The cross-welding system ensures the current is distributed as evenly as possible across the contact area. This vertical and horizontal grid-like nickel connection effectively reduces the overall internal resistance of the battery system. The assembled battery pack is then tested for its total voltage. The multimeter displays 2659V. The voltage of the cells is extremely consistent. Proceed to check the voltage of each series string to ensure there are no errors. All parameters are perfect before moving to the insulation wrapping stage. Using boards of FA4 fiberglass to protect the side panels. The smart JK BMS management board is securely mounted on top. The balancing signal wires are routed very neatly and secured with tape. Solder them securely. The signal wire ends into the battery cell poles. Connect the large heat-resistant silicone cable to the circuit's B port. And the main loads are securely connected to the P port. Plug in the secondary screen wire to start the BMS management system. The screen lights up, indicating the current capacity is 72%. Use the phone application to set parameters for the BMS via Bluetooth. 4. Declare the system capacity as 75 Ah and the quantity as 8 cells. Setting this up correctly helps the circuit calculate capacity and protect the battery optimally. Check the voltage deviation between cells on the screen, showing extremely low results. Test the 14 amp discharge current with an electronic load. The system operates stably. Attach an additional metal push button to turn the BMS power on and off. Now the entire battery pack is completely enclosed by insulating fiberglass boards. Wrap fiberglass tape diagonally to tighten the cover plates. Slowly lower this giant energy battery pack into the plastic case. Makita. 1. Cut the pine wood strips using a machine, cutting angles to make a support frame system. 2. Shoot wood screws to form a partition across the top of the battery pack. 4. Try placing the inverter circuit board on the partition to measure space. Start the process of modifying the case. Remove the round ventilation cover on the top. Use a ruler and marker to draw the cutting layout for the screens. 1. Use a jigsaw running along the lines to cut the ABS plastic surface. Scrape off the plastic burrs on the edges. Cut extremely carefully with a utility knife. 2. Dry fit the BMS LCD screen. It fits perfectly. 3. Use a step drill bit to create an accurate round hole. For the power button, 4. Continue cutting more space for the power meter. AC KVC. This process requires meticulousness, so the case surface doesn't get scratched. Dry fit the AC meter and switch into position. 1. Prepare the USB charging modules. Cigarette, lighter socket, and 220V power outlet. 2. Use a flat wood drill bit to quickly carve round holes for the DC socket cluster. Use pliers to break the plastic ridges obstructing underneath the box lid to expand space. Continue using the jigsaw to cut rectangular holes for the AC power outlets. Cut out a large empty square on the side to install the hot air exhaust fan system. The Makita jigsaw handles the thick plastic layer of the Makita case extremely smoothly. Smooth out the cut lines with a utility knife and a specialized flat file. These are 2 high current positive and negative copper posts used to output DC voltage. Make holes with a step drill bit and tighten the red copper post into the case body. Continue installing the black negative copper post in a symmetrical position. Use pliers to tighten the nut inside to ensure good contact. Firmly press the black AC power socket into the rectangular cut slot. Place the red LED cooling fan on the side of the machine. Screw it securely along with the protective iron mesh. Flip the case lid over. Proceed to install the blue LED exhaust fan into the round hole. 4. Proceed to connect the power wires for the cooling fan system using a soldering iron. The process of soldering the control wires for the switches and DC USB charging ports. Use high-quality solder and heat shrink tubing to seal the joints. The wiring behind the panel is routed neatly to avoid short circuits. Place the giant LiFePO4 battery pack back into the bottom of the case along with the AC inverter circuit. The cooling slot system on the Makita case helps the airflow circulate optimally. Reinforce the high current copper terminal for the red positive power cable. Pump solder to completely fill the terminal core. Use a multimeter to check the continuity again. Use a Makita drill to securely tighten the power cable to the inverter's connection terminal. Trim and strip the small AC signal wires to connect to the meter. This is the current sensor module of the KVC meter measuring from 50 to 300 V. Insert the LCD screen displaying AC power into the front of the case lid. Press the switches. The metal power switch with a red and green LED ring into the pre-drilled hole. Test turning on the screen switch. The BMS lights up brightly, showing the battery capacity at 100%. The central control panel is complete, with full voltage and discharge current parameters. The AC meter displays a voltage of 228 V, highly accurate alternating current. The interior layout is arranged very scientifically. The red LED fan is pushing out hot air. Testing the function of the USB PD fast charging port. The green LED indicates it is operating. Close the lid of the Makita drill case. Fold the side latches to seal the charging station. A perfectly rugged design, filled with technical character, with glowing cooling fans on both sides. Lift the power station up. The original carrying handle of the Makita case makes moving the heavy battery pack easy. Plug in the dedicated 29.2 V lithium battery charger to test the input charging port. Next is the stress test, under heavy load with a professional Bosch concrete hammer drill. Plug the Bosch drill into the socket of the 220 V on the portable power station. Pull the trigger and the drill's motor spins powerfully. The 1200 W inverter perfectly handles the starting current. Moving to the second test with a red angle grinder, equipped with a steel wire rust removal brush. Turn on the grinder and the screen displays the discharge current. The power surges and then quickly stabilizes. Unplug the grinder and plug in the Makita jigsaw. Load testing the third device on the charging station. Pull the trigger continuously and the jigsaw operates very smoothly, with absolutely no signs of losing power. The next challenge is a professional Bosch circular saw, a device known for its massive starting current. As soon as the trigger is pulled, the saw blade spins instantly and smoothly. The peak power on the AC meter spikes up to 500 double. But the charging station maintains an incredibly stable 227 V. The BMS screen reports an 18 amp discharge. It is clear that this power station is fully capable of handling specialized tools, operating durably in harsh environments. The power level reaches over 900 W when stress testing the hammer drill. The inverter system handles it calmly. Plug in a small handheld wood router for an additional test. The brushed motor screams powerfully. The ultimate test is connecting a mini arc welder to challenge and stress test the inverter system. Adjust the welding current on the mini machine to 144 A. Begin striking the welding rod against the metal bar. A blinding electric arc flashes, and the machine sparks very sharply. The AC power consumption skyrockets to 1722 W, although exceeding the rated capacity of 1200 W of the main AC board. The inverter still handles the instantaneous peak current well. Strike the welding rod repeatedly to test its peak load capacity. The portable power station still does not trip. Open the case lid to admire the internal components again. The technical specification label on the battery surface. First, moving on to the test of comfort with a mini air conditioner, providing a direct cooling airflow. Second, plug in the 264 W power adapter. of the air conditioner, connecting it directly to the 220V AC socket. Turn on the AC, and the compressor starts smoothly right away. The power meter reports an AC consumption of nearly 300 double. Third, the air conditioner blows out a cold breeze. That is incredibly refreshing. This power source is perfect for camping. The phone app reports the air conditioner's DC discharge current, maintaining steadily at over 21 amps. The AC screen displays a temperature of 22 degrees Celsius. The compressor runs very quietly without any voltage drop. Moving on to outdoor cooking utilities, which is extremely convenient. Place the multi-purpose electric pot on the floor. Connect the pot's power cord to the front AC socket. Turn the pot's power switch to the maximum setting. The AC power meter shows consumption jumping to 780. After just a few seconds, the water in the pot begins to simmer. The power supply capacity of the station is comparable to the household grid. The discharge current from the LiFePO4 battery pack remains within safe limits. Continuing to test the load with a high-power hair dryer. Turning on the strongest airflow setting, AC power jumps to nearly 1000 double. The cooling fans in the power station spin at a noticeably higher speed. The vents push out the warm air from the inverter. This power station truly is a versatile energy hub. Using the phone to check the BMS parameters one last time. All battery cell temperature parameters are still very cool. Lock the case latches tightly and store the machine. In conclusion, this power station has achieved the set goals. The 2 kilowatt-hour capacity is more than enough to provide power for a full workday. The compact and durable design of the Makita case is a highlight. The combination of LiFePO4 batteries and a pure sine wave inverter has created a device that provides excellent support on the construction site. Thank you for following today's machine modification journey. Don't forget to hit subscribe so you don't miss out on future technical videos. See you in the next upgrade projects. Goodbye, and have a productive workday. Ending with an image of the power station placed next to a professional Makita tool set